Hi, my name is Tuan Lee, and today I'll be reproducing the case study based on the report Automated Reverse Engineering of Relationship Between Data Structure and C++ Binary by Nick Collison. I'll be using Cheat Engine as a tool to demonstrate my uh, case study, and I'll be using Battlefield 2 as a game for Cheat Engine. I already pre-installed both. Gotta wait for it to load. And once the game is on, you go here, process list, and I gotta find Battlefield 2. This basically will scan the value output that we'll get from the game. At the same time, it will read and look for those output and give us an address where the set of instructions are located. I turn off the sound because it's a little distracting and it's not good for the audio when I'm recording. Uh, Let me open the game. Go single player, play easy difficulty, so it's easy for me to demonstrate how it's gonna work. What I'll be doing is creating unlimited ammo for my character using Cheat Engine. Right here again. It doesn't matter which gun we use. We just use the default one, the assault rifle. Again here, let me find a place so I won't die while I demonstrate this. Go here in the roof. So as you can see in the bottom right corner of the game, you can see it right here. Right here it said 30 ammo, or right in this area. It's not anymore. Give me a second while it load. Right here in the bottom right corner, it said 30 ammo, and we're gonna check for that value using Cheat Engine. Right here, the scan type exact value because it's the exact value we see in the game, and it's 4 byte because the ammo will show us an integer, which is 4 bytes right here. Let's put in 30, and the first scan it will check for any instruction that will give us a value 30. As you can see, there's a lot of addresses that uh, correspond to a set of instruction with the value 30, and we don't want to see any red because right now we're not doing anything, so the value doesn't change. So we can exclude any red changing value. So if I go back in the game and I take a shot, as you can see, it delete 3 from ammo, so now it's 27. And I will go in here, put in 27, and click next value. As you can see, it'll limit a lot of addresses right here, and there's only like 5 left. So if I go in one more and I shoot it again, it will decrease to 24. And I will now put in 24, scan it again. As you can see, it's the limit of the process. The more value you give it, the less address it will give, because other instruction address doesn't correspond to the ammo in the game. So since it doesn't correspond to the ammo, we can just ignore it. And since we decrease it to 3, and if you click on the address, it will give you the address, and all of them are 4 byte correspond to a different integer. And to find out, see if any of this set instruction is um, our ammo or decreasing ammo set instruction, we'll just deactivate them all. And as you can see, my ammo is not decreasing anymore, so that means one of this instruction correspond to our ammo. So let me go back out, and if I remove one, we have to only one of this is responsible for our ammo being decreased. Yeah, and if I remove one and I click, as you can see, it decreased. So that means the last addresses is our ammo. That it's related to our ammo. As you can see, only that instruction itself prevent our ammo from decreasing, because that addresses correspond to the set of instruction where every time we execute or we click on our mouse and we shoot, it will subtract some ammo based on what kind of weapon we're using. Since I'm using a assault rifle. I'm sorry, I'm a little sick right now, so depending on which weapon we're using, since I'm using the assault rifle, it decreased by 3 every time I shoot. If I use something else like a shotgun or a sniper, it will decrease 1 instead. So now we know that this address corresponds to the ammo to the decreasing of the ammo based on the action that we take. So if I go in here, right click, and find out what access to this is to read the instruction, which we don't need. But what we need is to write, to change the address. Go in here, click continue. It will take us to a debug menu. So if we go back, since there's no instruction right now, if we click it once, it will give us it will tell us which action we just took in the game, which is our ammo. If you double click on it, it will give you the set of instruction. Return 4, subtract right here in red is when we execute the action by clicking the mouse. It will subtract whatever ECX is from our ammo. Right here is 1, because even though it said 1, when we take a shot with our assault rifle, it shoot 3 times. So subtracting 1, 1, 1, 3 times, it will take away 3 of ammo. That's just how the game create the assault rifle. And right here, as you can see, it will set a pointer. It will compare to 0. Every time it get to 0, it would try to reload. But since we stopped this action, it will never get to 0. So our ammo never gone away. It will stay the same. So this is similar to the case study by Nick Collison he did in the report, where he will scan through and giving it different value every time he execute, and it will remove all redundant code and will look for any specific code instruction that he was looking for. So right now we kind of found it. So basically what we just did is we looked through a sequence. So every time we give it a value, and how it decreased from 30 to 27 to 24 to 21. We give it a sequence for cheat engine to look for. That's why the addresses that doesn't give the same sequence of output get removed. So it reduced to 3. And I guess other addresses also correspond to our gun, but not specifically decreasing the ammo. This specific address right here, it's removing each ammo, each integer from the ammo as we execute the action. And other actions also are related to the ammo, but not subtracting each integer. This right here is the code for removing each integer. So we can, since we already found it, we can try to save it, save selection file. I just save on my desktop, name it anything, I guess. Try to save it again. This is what's permanently saved. I just say remove. And what it does is we'll save it permanently, so the next time we go back in, it doesn't change anything. So we still have that code. We don't have to go through the same process again, where we have to take an action, then put in a next value scanning, and scan it over and over again. And that's the good thing about PSR, which stand for pointer sequence reversion. As you can see, I just died. But oh, the good thing about this is the pointer sequence reversal. So it doesn't have to run through the whole program to look for a specific instruction that we need. But what it does is it take a sequence and it remove anything that doesn't correspond with that sequence. It's avoid a lot of time taking. That's why it's better than other. Yeah, so the PSR just do a process of elimination where it will go by and remove anything that doesn't correspond with a value, and it would just eliminate it all, remove it, and keep the one that have the same corresponding value. And see, if we die and we go back out, even though we deactivate it, it doesn't change anything because it's the address is in the heap. Oh, as you can see, I got disconnected. But and value here. But the reason it doesn't change anymore after we die, because in the heap the addresses move around, so the addresses doesn't stay the same, and they give you that instruction set a new address every time. So I guess I didn't save it correctly, so that's why it doesn't work anymore after we die. To summarize this video, what I did was using Cheat Engine and connected with a game, in this case Battlefield 2, while running both Cheat Engine and Battlefield 2. We can see in real-time input. This is what I did when I input the value here, and yeah, and scan it. And, what Cheat Engine does is take the input we put in and compare it with real-time output produced by the game, and remove any unrelated instruction or addresses that connect to that instruction that doesn't produce the same output using pointer sequence reverser or PSR. This case study showed that PSR is faster and more accurate than to scan any whole program, which can take hours. As you can see early in the video where I show when I just put in one output, and it showed like maybe hundred of addresses. Imagine if I don't put in that output, and there's gonna be a lot of addresses per instruction. Since it's a game, there's gonna be thousands of line of code, and each line of code, each instruction will correspond to a specific address. It's gonna take a long time, and it's gonna be a lot faster and more accurate than using manual reverse engineering method, as said in the article, because it's a game is a huge file. You can't really look through and find a specific instruction without knowing like the sequence or any output or the addresses. Since we don't know the address, we can't really look into where specifically where it is. We have to go through different method procedure, maybe one by one, and This method is like a process of elimination, which cut the time and uh, how is it, the data a lot down, so it'd be a lot faster, more efficient, more accurate. It pinpoints to exactly where the instruction will show the output is. And thank you for listening.